Today we're going to be talking about the distance formula. What the distance formula really is let's say we have 2 points A and points B. We want to figure out how far apart these 2 points are, or what distance D it is to go from point A to point B. In order to do that, we need coordinates of these points. So let's take a look at our formula. The distance D between 2 points A that's located at x sub 1, comma, y sub 1, and point B, which is located at x sub 2, comma, y sub 2. Now, these are not powers that you see here. These are just little subnotations to denote the difference between this x and this x here, this y and this y here. You notice x1 and y1 always go together. x2 and y2 always go together for points. The distance formula is this sort of complicated looking formula you see right here. D equals the square root of the difference between the x's squared plus the difference between the y's squared. Now, one question I'm always asked is, does it matter whether or not it's x1 minus x2 or x2 minus x1? It does not. So it doesn't matter which one you put first and which one you put second. Just a rule that we usually do is, whichever x you put first, put the y first in the other one that comes from the same point. It's just mathematically a little bit better to work with. Okay, so let's start taking a look at some of these. So, find the distance between the points -3, comma 1 and 2, comma 3. So D equals, I always like to have a nice big square root symbol here. Take one of the x's. I'm going to start with -3, parentheses, so -3 minus the second x, which is 2. Remember to square it. Plus, now we have to subtract the y's. Since I started with this x, I'm going to use this y first. 1 minus this y of 3. Now be very careful when you do this. You don't want to make sure. I've seen a lot of students do -3 minus 1 from the same point, but these are x's and y's. We have to subtract the x and the x, the y and the y. All right, now it's down to doing some computation. So, order of operations say we do inside parentheses first. -3 minus 2 is -5 squared, plus 1 minus 3 is -2 squared. So D equals the square root of -5 squared. Remember, whenever you square a negative, you get a positive. So 25 plus -2 squared is 4. And when we add these up, we get the square root of 29. So the distance between these 2 points is the square root of 29. The question is, can we simplify this? The answer is no, because 29 is prime, so we can't break this apart. One thing I want to pinpoint here is, when you look at this, I find a lot of students that will take the square root of 25 and then add the square root of 4. You have to add the inside first before you take the square root. So don't take the square root of these individual terms. Simplify inside that square root first, and then once you get down to a single number, see if you can break it apart. Let's take a look at another problem. Okay? So, find the distance between 7, comma 3 and 1, comma 5. So D equals the square root of, take our first x, 7, subtract the next x, which is 1. Don't forget to square it, plus the first y, which is 3, minus the second y, which is 5. And then we keep going. D equals the square root of 7 minus 1 is 6. I always like to put parentheses around whenever I do my operations on the inside. Plus 3 minus 5 is -2 squared. Now let's do our powers. D equals 36 plus 4. D equals, add 36 and 4 and get 40. So that should be our answer, but the question is, can we simplify this? Is there any perfect square factors of 40? And the answer is yes. 4 goes into 40. So we can break the square root of 40 into the square root of 4 times the square root of 10, like we've done before. and d equals 2 square roots of 10. And that is our most simplest answer. Some of our answers, as you see here, will have square roots as part of them. And make sure to simplify your answer as much as possible. Let's take a look at one more of these before I let you try some of these out. Okay? So, d equals, we have the distance between 1 comma 6 and 4 comma 2. So we do d equals the square root of our first x, which is 1, minus 4 squared, plus our first y, which is 6, minus 2 squared. So d equals the square root of 1 minus 4 is negative 3 squared, plus 6 minus 2 is 4 squared. d equals the square root of negative 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25. And is there a square root of 25? There is. D is a nice 5. Now, one of the things I've noticed students do is they kind of leave off this square root as they're doing the work, and sometimes they forget it. So make sure all your work is there in each step. Why don't you take a break here, pause the video, and see if you can try 4 and 5 on your own, and then I'll walk through them with you. Okay, so why don't we take a look at number 4. Find the distance between points negative 2, 4, and negative 1, 5. So let's start off. Here we go. Oops. D equals the square root of negative 2 minus negative 1. A lot of times I'll see people just do negative 2 minus 1, but it's really negative 2 minus negative 1. And we're going to square that. Plus 4 is our first y, minus 5 squared. D equals the square root of, well, minus negative 1, that just becomes a plus 1. So negative 2 plus 1 is really 1. Plus 4 minus 5 is negative 1. Oops, I forgot the square. Let's remember that there. And this is negative 1 squared. D equals the square root of 1 plus 1, or D equals the square root of 2. Nice, neat numbers right there. And again, let's see whether or not your number 5 worked. Okay? So, D equals the square root of, take our first x, 1, minus, our second x is 10 squared, plus our first y is 4, minus negative 8 squared. Again, don't forget, when you subtract a negative, make sure both negatives are there to start with. D equals the square root of 1 minus 10 is negative 9 squared, plus 4 minus negative 8 is really 4 plus 8, or 12 squared. D equals negative 9 squared, don't forget the square root, or 81 plus 144. D equals the square root of 225. And can we simplify the square root of 225? We can. It turns out to be a perfect square. D equals 15. Hopefully those problems worked out just like yours did. This is all for today. I hope you have a great rest of your day and enjoy doing the homework on the distance formula.